Welcome to Topic 6, Law of Cosines. We worked with the law of sines last class, and the law of sines is setting up a proportion. And we use law of sines when we have angle, angle, side, or angle, side, angle, when we know two angles in one of the sides, or when we know side, side, angle, in which we know two sides and the angle that's not in between. Today's going to be the law of cosines. And the law of cosines we're going to use when we know side angle side, which is two sides and the angle in between, or we know all three sides and we want to figure out one of the angle. Law of cosine is probably going to be a little bit more work than the law of sines. One case will be an easier case, but one case will be a little bit more difficult case, and we'll go through everything today. First, we're going to look at some random ABC triangle. It's not a right triangle right now, but we're going to draw an altitude. So altitude K is right here, is the height of this triangle using AB as the base. So right here it's perpendicular. Okay. The other thing we have is that this side AB, this total length of AB is equal to C, and we're splitting it up into two lengths, x and C minus x, because if you did x plus C minus x, you would get a total length of C. So we have C minus x and x. But what I've done is, by drawing this perpendicular, this altitude, is I've created two triangles. I have one here on the right. I have one here on the left. So you see this triangle here, that's on the left, and this triangle here, that is on the right. So if I want to use Pythagorean theorem, and everyone should know Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the legs, I could do the left triangle, and I get k squared plus parentheses c minus x squared is equal to the hypotenuse b squared. If I do the one on the right, a little bit easier, I get k squared plus this side here, x squared, is equal to the hypotenuse, in this case is a squared. Okay? So right now you see we have set up the Pythagorean theorem for both triangles, and they both have something in common. They have k's and x's and this and that. So let's see how we can manipulate them a little bit. So we see both of these equations have a k squared in them. So I'm going to isolate the k by subtracting this over to the other side. Oops, made a little mistake. That square is on the outside of the parentheses. I'll fix that in a second. I could subtract this over here, and I'll do this left one. I get k squared is equal to b squared minus the quantity c minus x squared, and the right one is k squared is equal to a squared minus x squared. So I have two equations, both say k squared. Why is that important? Because when they both equals k squared, I can make them equal to each other, and that's what I'm going to do in the next page. So the first thing I did was take those two equations and set them equal to each other, and I'm going to expand this and rewrite it a little bit. So first thing I need to do is do that c minus x squared. So c minus x squared is really c minus x times c minus x, and hopefully you learned in Algebra 1, and I understand if you didn't. I could expand this by doing this double distribution. I get c squared minus cx minus cx again plus x squared. So this whole thing is equal to c squared minus 2cx plus x squared. That's what it equals to. So now I could put this into the equation, into the right equation. B squared minus parentheses c squared minus 2cx plus x squared equals the blue equation of a squared minus x squared, and I could distribute this negative sign. I get b squared minus c squared plus 2cx minus x squared is equal to a squared minus x squared. And then I notice that I can add x squared, and I can add x squared, which is nice. These go away, and I get b squared minus c squared plus 2cx is equal to a squared. And then I could add this and subtract this. And what I do to one side, I do to the other side. And finally I get b squared is equal to a squared plus b squared minus 2cx. I've solved that equation for b squared. Now I'm going to move this up and figure out how can I eliminate that x. So I'm going to go back to that first page. And I'm going to use this part of the triangle right here. I'm just going to use that part of the triangle. So going back to that first page and using that right half of the triangle, I have a right triangle here, and I realize cosine of angle B is equal to adjacent over hypotenuse, or cosine of angle B is equal to side x over A. Okay, well that's important to me because I can manipulate it, and I can solve this by multiplying by A here and A over here. So I get x equals A times the cosine of angle B. And then what I can do is take this equation here and I can rewrite it. Because every time I see x, I can rewrite it as b squared is equal to a squared plus c squared. I made a mistake earlier. I'm going to have to erase that. That should be c squared. You're going to have to get with my mistakes. I am not redoing videos. C squared minus 2 times c times a cosine of b, because all I did was put this in for this part right here. That stood for the x. And now I have a brand new equation. So when I can solve for a whole side, I'm going to write it in a better order. B squared is equal to a squared plus c squared minus 2 times a times c times cosine of angle b. If you notice, whatever side I have here is the same angle I use here. And I'm using the other sides. So when I start with side B, I get that. Now I could do it for any letter I want. So when I do it for side A squared equals, I have to do side B squared and side C squared minus side 2 times side B times side C times cosine of angle A. Like I said, whatever side I have here, I have to use the angle here. And then finally, c squared is equal to a squared plus b squared minus 2 times a times b times cosine of angle C. And again, this side has to match this angle. This is the law of cosines. It's a much longer equation than the law of sines, but it's useful on different types of triangles that we will go through. Okay, so the law of cosines is like the law of sines. It could be used for any triangle. It does not have to be a right triangle. So here's any triangle ABC with its corresponding sides. And here are the three ways I could write it, depending if I'm looking for side C and using angle C, or B and B and A and A. So when I have to find side C, Side C is over here. And I looked at what type of triangle I have here. I have a side, an angle, and a side. So this is side, angle, side. And actually this is going to be the easy case for the law of cosines. Well, because I had to solve for side C, I'm going to use c squared equals blah, blah, blah. That's the equation I'm going to use for my law of cosines. So I have c squared equals a squared plus b squared minus 2 times a times b times cosine of angle C. Make sure you always match up whatever side you're looking for. You match up to the angle that you're going to use. And then I could just plug in c squared is equal to a squared, well this is side A, this is side B, so in this case 19 squared plus 27 squared minus 2 times 19 times 27 times cosine of 80 degrees. And this is where it's really nice. I could put this all together in one step in the calculator, because there's no variable on this side of the problem. The variable is on the left side, which we're solving for. So I'm going to show you how I can do this all in one step in the calculator. So I can let the calculator do all the hard work for me. I just type this in one step in the calculator. I hit enter. I get that number. So remember, that's not side C. That is c squared. So c squared is equal to the 911.837 number. So how do I solve for C? I just have to take the square root of both sides. So I go back to my calculator. I could hit second, the square root key, and I taught you how to cheat a little bit. I could come up and highlight that number, hit enter. I don't have to type in anything. And here's my result. C is 30.2, and the units on this is meters. Not too bad. So for this one, we have to find angle C. So we have to recognize what type of triangle we have, and I notice I have all three sides. So this is a side, 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 and this one is going to take work to solve for angle C. Again, since I have angle C, that means I have side C. I'm going to use that c squared equation that I used before. So I just type in what I know. A is A, B is B, and C is C. It doesn't matter really so much for A and B because they're pretty much interchangeable. It is important to know that C is first. So 14 squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 times cosine of angle C. I do not know angle C. That is what I'm solving for. Now, it is very important to understand that not all things can be typed in all together in the calculator. What I need to do is that, obviously that goes together. These two are separate from this. The 2 times 9 times 6 times cosine angle C is together as one term. The minus 2 times 9 times 6 does not go with the 9 squared plus 6 squared. So these go together and these go together. And if I go to my calculator, I get 196 is equal to 9 squared plus 36 squared is 117 minus 2 times 9 times 6 is 108 cosine angle C. That is all together with that. Okay. These do not go together. That 108 is connected with cosine of C. It's not part of the 117. Well, so what I can do, I can subtract this 117. I get 79 equals negative 108 cosine angle C. Do not drop this negative sign. Okay. Now I can divide by negative 108. Negative 108. It's not 108, that's 18. 108. I go to my calculator. I get negative 0.7315 is equal to cosine of angle C. I drop to C. Okay, so we talked about whenever we solve for an angle, when we solve for an angle, we do have to use inverse trigonometry, in this case inverse cosine. So I'm going to use inverse cosine here, inverse cosine here. These cancel. So angle C is equal to inverse cosine of negative 0.7315. And actually I'm going to do this on the calculator a little bit. I'm going to do 79 divided by negative 108. To get with that number that I had before, I'm going to do second inverse cosine. I'm going to cheat and use that number and hit enter, and I get 137 degrees. So I'm going to go up a little bit. Angle C is 137 degrees according to my calculator. Okay. I'm going to go on the next page. And let's see where we're at. I'm going to flip out of this for a second. Let's shrink it up. Okay, let's see what we can do here. So before we go on, let's talk about what we should use and when we should use it. So when I want to use law of sines is because I have angle side angle, angle angle side, or side side angle. That's the law of sines. And when I want to use the law of cosines when I have side 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 or side angle side. Okay, I could use the law of sines to solve for a side, or I could solve for another angle depending on what I want to do. But to me, if I'm going to use law of cosines, I should always try to find the biggest angle first. And if I have law of sines, if I had a choice between an angle, I'm going to take the smaller angle first. It's usually the better choice. So for this example, let's see what we have here. Looks like I have angle angle side, which means I should do the law of sines. Okay, that means first I can easily do angle C. Angle C is 180 minus 109 minus 34. So angle C is pretty easy. That is 37 degrees. Okay, so this is 37 degrees. And then I could do, let's see, what do I want to solve for first? Well, let's do B and C. So side B over sine of 34 is equal to 22 over sine of 109. And actually side C over sine of 37 is equal to 22 over sine of 109. That's sitting in both problems, and it's pretty easy to solve for this. To get rid of that, I multiply by sine of 34. I multiply by sine of 37. And if you go to your calculator, you get side B is equal to 13. Side C is equal to 14. So I have 13 centimeters, 14 centimeters, and 37 degrees as the missing pieces of that triangle. Okay, When I recognize this triangle, I notice I have a side, an angle, and a side. So side, angle, side is a law of cosines. And actually this is the easy one, law of cosines. I could do, C is over here, so C squared is equal to, this is side A, this is side B. It doesn't really matter. You could interchange them. Minus 2 times 20 times 13 times cosine of the angle is 93 degrees. You can put this all in one step in your calculator. We get C squared is 596.215, and I square root everything. I get C is 24.4 inches. Now let's do angle A. Doesn't really matter. So sine of angle A over side A, which is 20, is equal to sine of 93 over, well, we just figured this was 24.4. Very easy to get rid of this. Multiply by 20. Get sine of angle A is equal to 0.8185. And again, whenever we solve for an angle, we have to do inverse trigonometry. So I have to do inverse sine here. I get angle A is 54.9 degrees. And then when I want to do angle B is 180 minus 93 minus 54.9. So I get angle B is 32.1 degrees. Not too bad. Okay, the last 2 pages of the notes will be posted. I'm not going to put them on the video. I will go over them in class. So if you're watching on Zoom, you can watch on Zoom, or you could just pay attention. But I don't really want to make this video any longer than what it is. Okay, ask questions.